So we're moving on to the final chapter to do with algebra, and to add on a few further skills, revise a few things that you would have done at junior certificate, and then add a few extra skills on top. So today is about revision, and particularly about what we call inequalities. So not an equation with an equal sign, but an inequality with a less than, more than, greater than, less than. So I'm going to go through a few examples, explain the key points. So just as a recap, we obviously have the idea of an inequality, greater than, less than, or if you have a line next to it, it's greater than or equals, and less than or equals. And if you have an equation, you can solve that equation just by a standard process of sort of the balancing process. So let's just say, for sake of argument, we had something really straightforward, like 2x plus 7 is equal to 15. Well, I could take away 7 from both sides, and I could divide by 2, and I would get my answer. So this would be exactly the same if you had not an equation, but an inequality. Okay, exact same process would occur. There is one thing to be aware of with inequalities, and I'll mention that in a moment, but apart from that, you can treat it just as if it was an equation and go through the process in the same way, doing opposite operations on a balanced process to get your final answer of x is greater than or less than a certain number. The other thing that you need to be aware of is the idea of the number sets. So if you think of natural numbers, and if you think of integers, we have rational numbers, although that's not really of concern to us today, and we have real numbers. So natural numbers basically is the whole numbers starting at 1, so 0 is not included. Okay, and it's just the natural counting numbers. Integers are all possible numbers that are whole, whether they be negative or positive, it makes a difference. So basically, it's all the natural numbers plus, in addition to that, 0 and the negative versions of those whole numbers. A rational number is simply anything that can be written as a fraction, where a and b, the numerator and denominator, both must be integers of some sort. We're not really concerned with that today, because in terms of thinking of an inequality, generally speaking, when you're asked to solve one, you're asked in the context of your answers being either a whole number, a natural number, or an integer, or a real number. And a real number is basically any number, okay, including all of these, all the counting numbers, all the negative whole numbers, all the fractions, but also other numbers such as pi and square root of 2, and it's basically any number that can be represented on a number line. So let's just remind ourselves about a number line. If we think of a number line with 0 there, we've got all our positive values in this direction. We have all our negative values in this direction. So we could say there's 1, there's 2, 3, 4, and so forth, moving that direction. And the same in the other direction, we've got -1, -2, -3, -4. And we can plot values on that number line. So the number 1 is here at this point in time here. I can either put a dot sort of on the line. I could also just put it just above. Now, the benefit of putting it just above is it doesn't get sort of lost on the number line. You can at least see things if it's just above the line. I know a lot of textbooks do it on the line, but I find that you can't really see if you've got an arrow or a line or even small dots, or if you're, whichever way you're writing, it's easier if you just have it just above the number line. So that's number 1. If I want to represent all natural numbers, it would be 1 and 2 and 3 and 4, and obviously I'd carry on. Okay, now I'm not going to bother carrying on 5, 6, 7, 8. We're taking, because my line carries on beyond 4 with an arrow there, we'll accept that we would carry on. I suppose I could put in 5 as well, since I've got the space for it. Okay, but we would appreciate that the natural numbers are represented by those. Okay, if I were to talk about the integers, in addition to those numbers, okay, I would also have to have 0 and -1 and -2 and -3. Then finally, if I want to represent real numbers, that will be done with an arrow. I'll give examples in due course. Now, just to give the example of this example here that I looked at here, how would I represent that on a number line? Well, I have to appreciate that it's all numbers greater than 4. Okay, so how would I just put 6 in there as well? So how would I represent that? Okay, so it depends upon how the question starts. So when the question is given to you, sort of, there's the question, okay, solve that, right, okay. But it will also not only say that, it will also say that x must be either a natural number, or it might say that it's an integer, z, or it might say that it's a real number. Okay, so let's just go through each of those different examples. So what if it was going to be I'll start with the basics. Let's start with a natural number. So a natural number is any positive whole number. So any positive whole number greater than 4, well, that'd be the number 5 and number 6. And I would obviously carry on with 7, 8, but I don't need to. There's the arrow showing that I would carry on with my list. But that is the graphical representation of that inequality, of this solution, x is being greater than 4. By the way, if I was being asked to list them, okay, I would just literally list, 5, 6, 7, ... and put it in curly brackets. Just like a list, like a set list. So what if I was asked for it not a natural numbers? What if I was asked for it as an integer? Okay, well, it would actually be exactly the same thing in this instance. Okay, it'd be no different because there are no negative numbers or 0 that fits within this solution set. Now, lastly, with real numbers, what would it look like with real numbers? Well, what you would do is you would show real numbers with an arrow with a starting point usually, or a line connecting to a start and a finish. So for real numbers, okay, it's all values. So obviously we're talking about not only anything above 4, so 4.1, 4.2, 4.3, 4.4, all of those numbers in there, every single possible conceivable number. Okay, so we show that with a line, with an arrow, I suppose, pointing in direction, so it's greater than, so it's pointing up, and we want to represent that it starts at 4, okay, but we don't want it to be 4. For it to be 4, you'd actually have to have a line there within your inequality. That's not what we got here, so we would actually have, essence, an empty dot, or a sort of a small circle, I suppose, at 4, that would represent that we're starting at 4, but we don't include 4. If it had been the case that the question had that extra inequality sort of equals to type bit to the question, then in that instance I could fill in 4, because 4 would be a solution. So that's your revision, I suppose, from your work on junior certificate. So what I'm going to do is I'm going to go through some examples and explain them fairly quickly, hopefully. You'll just remind yourselves. So here's the first example. Now, when you're looking at these, you need to break down the question. It gives us an inequality there. Okay, that's the inequality. Now, the bit after the comma is simply the extra bit of information that tells you about that. And you shouldn't, you need good eyesight, and you spot that there's an actual comma there, and that's not 2x, that's plus 2, the number, and then separately you have a completely separate bit of criteria which refers to what possible values x could be. And in this case, it's going to be any integer value, any positive or negative whole number. Let's go through this question. Let's solve it. So we take our inequality, and we say to ourselves, well, we can take away x from both sides, bringing the x on the side where there are more of them, and then we can take away 7 from both sides, and we will get -5, and then lastly I can divide by 2, and I get anything that's greater than or equal to -5/2, which is -2.5. So if you think of that on a number line, okay, what would that look like? Okay, there's 0, and these things can tend to be fairly sort of sketched. You can see I'm not making too much effort to make it look particularly good. Okay, and there's 1 and there's 2, and I start giving up with bothering with the rest of those. It doesn't really matter. Okay, so the key thing here is it's integer values, so it's going to be dots. Okay, and it's any number, any whole number that's greater than minus 2.5. There's minus 2.5, so any value greater than that would be minus 2, minus 1, 0, 1, 2, and 3. And obviously we'd continue on there. Okay, and you just know that it carries on in that direction. And the reason why the arrow, in a sense, is showing we're carrying on in that direction. Next example, we've got our inequality there, and separately we've got our criteria. It's telling us that it's only a real number, so it's going to be any value. It's not going to be restricted to integers only. It could be any number, so we're going to be representing with an arrow when we come to graph our solution on a number line, as they say. So let's go through this. We have these fractions in front. Now, just very quickly, whether you see those fractions as written, or whether you see it in this sort of way, where you've got a denominator, I suppose, best way to describe it, it doesn't really matter. Whatever sort of you like, or deal with best. Likewise, in terms of how you deal with those, at the end of the day, if I multiply everything by 6, okay, if I both multiply this side by 6, I get x minus 1. If I multiply the other side by 6, well, actually, just very quickly, if I were to multiply by 6, okay, let's just show that there. What you're going to get is the 6 and the divide by 3 summarized to be the multiplier of 2 by 2. So we have x minus 1 is greater than or equal to 2x minus 8. Now, I mentioned in the last example, about putting the x on the side where there are more of them. So I would always, here I've got 1x on the left-hand side, I've got 2x on the right-hand side. Now, my attitude to solving equations, you always put the x's on the side, the unknown on the side where there are more of them. It makes my life easier, and it involves less negatives, and in particular with inequalities, it avoids you making one crucial mistake, which I'll mention in a moment. So let's take away x from both sides. Let's add 8 to both sides, and we end up with being x, working backwards, right to left, x is less than or equal to 7. You can write that the other way around. If you're going to write it the other way around, you have to point the inequality in the other direction. Okay, so the x is still pointing towards the inequality is still pointing towards the x. Okay, x is less than or equal to 7. So in terms of a number line, okay, and to some extent you could actually get to a point where you're showing very little of the number line at all. Okay, it's just the key features. And so my number line is any number less than or equal to 7, which is a real number. So it's going to be starting at 7, including 7, because there's that line there, and it's anything less than that. So my arrow just points downwards, down below 0. And that's all I actually need to show in terms of my graphing. I don't need to show 1, 2, 3, 4, 5, 6 in between, or minus 1 either. It's just the key bits of information. Because it's a real number, it's just all numbers. I don't need to specify the integers in between. Just very quickly, to go back to my point about the issue around making sure the x's are on the same side. There's one sort of no-no you need to be very, very careful of. So let's go back to this line here we had. Okay, so I open up the brackets. And let's blindly bring the x's onto the left-hand side. So take away 2x, I get minus x. Let's add 1. So I get minus 7. And that normally if it was just a normal equation, you just blindly say, sure, well, if minus x is greater than or equal to minus 7, then I can just say that x is greater than 7. And this is incorrect, okay? This is wrong. The answer is wrong. You can see it's wrong. That's the correct answer, which is complete opposite of what it's saying here. X is not greater than 7, it's actually less than 7. So what has happened here, okay? You should know from your junior certificate studies that you should not multiply or divide an inequality by minus 1. Okay. Now I did that, and that's the no. That's the thing I shouldn't have done. I should not have multiplied both sides by minus 1. The only, I suppose, thing that gets you out of jail on this one is if you are going to do that, okay, and my attitude is you shouldn't put yourself in the position in the first place, but if you are going to do that, then you should make sure that you change the direction of the inequality. Okay, so my preferred option is just making sure you never actually put yourself in that position. But if you're going to do it, okay, just make sure that if you have a negative unknown, okay, with an inequality, when you turn it into a positive unknown, okay, just by that trick of, in a sense, multiplying by -1, you must change the direction of the inequality.